cosine of the sine, then you can say always. But you can't just say always for just any two transcendental.
All right, I got it.
Yeah.
Wait, what did you do on the black?
The first part or the second?
The last, yeah,
Down here?
yeah, the black.
You mean how did I go from green to black or black to red?
Green to black.
I added this over here. So I've got a 1 integral of e to the 2 theta sine 3 theta d theta plus 9 over 4 integrals e to the 2 theta sine 3 theta d theta. Well, one of them plus 9 over 4 of them, this is 4 over 4, plus 9 over 4 is 13 over 4. That's where this came from.
You added that one?
Well, yeah, I'm adding this. I guess I could write it out. What I'm doing is I'm adding 9/4 integrals e to the 2 theta sine 3 theta d theta to both sides. So when I add this to this, right here, over there, it cancels. Questions?
For these problems, do you usually always let u be your trig function?
Nope, doesn't matter. In fact, I believe when I did an example of this on Friday, I set it up the other way where I had u be the exponential. What matters is that you know that you're going to do this 2 times and that you set it up the same way both times. If u is the trig function here, then u has to be the trig function here. If I had made u equal the exponential, that would have been all right, but I would have had to have done the same variable assignment there. Question. These are the right questions to be asking. Number 33. 33, oh my, what is that? Sine of the ln of the cosine. 0 to pi over 2. Well, we can see one simplification that will immediately arise. This is before integration by parts or anything. If I let u equal cosine theta, then minus du is sine theta d theta. So that would probably be worthwhile. Notice you can rewrite this integral as the integral from 0 to pi over 2. Ln cosine theta times sine theta d theta. So this is probably a worthwhile step. This will now become the integral from where to where? What will be the new limits of integration? 1 to 0. That will be ln u, and then sine theta d theta is minus du. And we can get rid of that minus sign by exchanging the order on the limits of integration. So I'm now going to write that as ln u du from 0 to 1. Did we do that right? Yeah, actually, I think they have a mistake on this. Did I copy that correctly? Is that a pi over 2? Very good. Thank you for correcting it for me. It'd be nice if you'd catch those things at the beginning. Somebody tell me why looking right here, I knew this one was voted the way we've written it down.
Because cosine of
Pi over 2
is 0.
And ln of 0 is
1 over 0.
Is
Undefined. Undefined.
So you can't integrate something against a vertical asymptote, can you? Hang around for a couple hours. Okay, actually, we won't do that today. Did we do that in this chapter? It might be the next chapter. we will be looking for a little section called oh, it is this chapter. 7.8, we'll come back to that problem. Turns out we can do it with the pi over 2 in there. But right now, we would not be able to. So fortunately, this was a miscopy.
You know what I love about math? It's impossible to do it until we tell you that you can do it.
I don't know anything about math except for having it over. So if I do that now, this is not a 0 up here, which is good because we can't do the ln of 0. Rather, this is under the substitution, the cosine of pi over 3, what is it? 1/2. So now our integral doesn't go from 0 to 1, it goes from 1/2 to 1. Much better. Of course, we're still up against an ugly problem. Although I think, didn't they do this one for you in the reading? Anybody like to do the reading? I guess I will see. I thought they did this one for you. Don't they integrate the ln somewhere? Yes, they do. It's example 2 on page 513. So you either have the choice on this one of memorizing the integral of the ln, or you can redo the work that was done in example 2. What do you want to do? Okay, good. I'll memorize. So there, I found out that this is going to be u ln u. Isn't it minus u?
Yeah.
Where is it? It's example, I just said it, minus u. And we're evaluating that from 1/2 to 1. So there are some advantages to reading the textbook, are there not? Right? We didn't have to do any further work there. This is a previously solved problem. It'd be like if I asked you to integrate the tangent. What are you going to do? Are you going to really integrate it, or are you going to have memorized what we did before? Everybody know what the integral of the tangent is? ln absolute value secant x plus an arbitrary constant. So this is, if I now plug in 1, if I now plug in 1, what do I get? 0 minus 1, let's go ahead and be complete, minus, and now let's plug in the 1/2. All right, 1/2 ln 1/2 minus 1/2. Is that good? So what do we get there? It looks like minus 1/2 minus 1/2 the ln of 1/2. Is that right? Question. Fun stuff. I wish I could say that the integrals get better, but unfortunately I gotta say that they get worse. But I'm sure we'll handle it well. Is that okay? As good as it's gonna get, apparently. 37.